Welcome, and thank you for choosing this IBM recording. Special thanks to Samsung for this great opportunity to connect to microelectronics worldwide. My name is Isabel de Sousa. I'm a packaging engineer at IBM, and today I would like to present solutions from design to high-volume manufacturing for your cutting-edge applications. I would like today to touch base and give you an overview of our facility and give you examples of the type of advanced packaging solutions we can provide. I'll go into some details on how we proceed to do menu qualifications for easy implementation of manufacturing at our facility, and some building blocks that are particularly handy for some cutting-edge applications that are current today. And I'll give you a brief summary of the OSAT services we can provide to our customers. To start things off, a few words on who we are. We've been processing IBM hardware for their computers and mainframes for over 45 years now. And you see here an aerial image of the plant where I work. So it comprises over 850,000 square feet of assembly and test process floors. And in 2012, in collaboration with University of Sherbrooke, we opened up a development center that lies right next to the main site plant. This collaboration center is where we do all our development, and it's a great center which fosters innovation and gives us access to academia and other manufacturing companies that use this facility. In 2015, IBM, you may know that IBM divested their wafer fab, so we became a full OSAT that's open to doing assembly on any wafer source. And up to this day, we continue doing the assembly and test for the main components that go in IBM's mainframe computers. And we have a number of customers using our OSAT services. So based on this short history, we certainly have some specialties. So there are some markets that are really markets of choice for our OSAT operation. One of them, of course, is no surprise since we've been doing assembly for IBM computers and mainframes for a number of years. So we're particularly well versed for mainframe hardware, high reliability hardware, and high performance computing hardware as well. Another area where we have strengths, given our background on packaging ASIC wafers for our wafer fab, we developed expertise for datacom fabric like switch modules and other elements that go into the datacom industry. More recently, we've developed expertise in RF, system and package, and optoelectronics that are particularly well suited for the telecom industry. To illustrate how we serve these markets, you have a number of configurations, of module configurations that are illustrated here on this page. So for our mainframe activities, we provide assembly of large SCMs and DCMs and multi-chip modules. And we have, over time, we have developed very successful applications for system and package for a number of customers. And we have specialty assembly techniques for high performance computing, for combining high bandwidth HBMs with CPUs, doing chip partitioning examples, And we've developed also a photonics know-how that we think will be particularly useful for the datacom challenges that are coming on the market. Here I try to illustrate the particular challenges attached to qualifying large die and large carrier packages. So we start off with a rigorous set of design ground rules, and we drill down through the processes to make sure that the materials, the processes are optimal to mitigate the stresses that might develop at delicate interfaces in these packages. So, and one of the elements that we particularly like in this strategy is the design for test, so that we could have a rapid loop back and feedback loop to make sure that everything is in line and accelerates the high volume manufacturing process. So for those who follow the microelectronics news, it might not be a surprise to learn that IBM has turned to Samsung Foundry for providing the wafers and the chips for the most advanced mainframes from IBM. So here you see illustrated the Power 10 processor chip with a 16 core. So you know, it's one of our most recent qualifications on 7 nanometer nodes, and it meets the stringent requirements for thermal dissipation, signal integrity. And this qualification, of course, focused on a large package, a server CPU, and we always perform extensive reliability testing and make sure that we have robust packaging solutions for this type of component. And here you have some of the main metrics that we qualify and that we included in our menu qual. So you see the base menu coverage that is available to customers that come for OSAT services here. So you see some of the highlights, the extended menu coverage that we obtained, that we exercised going from 14 nanometer to 7 nanometer. So we increased the chip size by about 20%. We reduced the interconnect pitch, are working on large substrates. The base qualification is now at 70 millimeters, but we're currently working on 105 millimeter substrate. We've extended the build-up stack structure, worked with various core thicknesses. So we are well equipped there to answer several of the base requirements of our customers. And of course, we're open to qualifying some special applications that are more stringent or go above this basic menu qualification coverage. And menu coverage is not only about metrics, of course, and package size. There's a lot of processing know-how that go into there. And I'd like to highlight some of the unique features that we can provide as an OSAT. So, of course, IBM is an expert at C4 interconnects and chip interconnects, and we've reached high yields and very low defect chip soldering assembly processes. But over that, I think we've had unique IP to circumvent white bumps or ghost bumps that are typical of ultra-low K dielectric materials that are more fragile as nodes decrease in size. So we have an approach to make the interconnects more compliant by process. And we also have excellent approach to get superior cleanliness, and we even have a fluxless joining process, which is very handy for optical interfaces which might be sensitive to watermarks or solvent residue. And the name of the game to mitigate CPI interactions is really underfill, and we're really masters at implementing capillary underfill processes that are very well matched to the applications. We have achieved void-free processes, and we continually track the market, survey the market for the most advanced underfill materials that best suit our needs for the packages that we harbor. And of course, given the business we're in, thermal mitigation is key, and we work with high performance tip material. I'll give some more detail in the next slide. We also have a proprietary process that guarantees low variance coplanarity, and also a very well controlled bond line and consistent bond line from lot to lot. And we have highly automated ball attach processes that can adapt to specific needs that come from the customer. We can implement hardball, standoffs, and different alloy for specific. Here you get an overview of the thermal situations that we can provide. So we have a standard offering and enhanced offering that we use in our current CPUs for mainframes. So this enables a very good thermal dissipation rating, and as I mentioned, low variability on warpage and bond line thicknesses. We also have the ability to really tailor the solution, the thermal solution, to the application. Here you see we illustrate a dual component module which have very different thermal requirements, and when required we can isolate some components that are more sensitive to thermal incursions by doing a split, splitting the lid, and accommodating also for specialty connectors that might need to be connected to the edge of the module. In the next few slides, I'd like to provide additional information on the high-density interconnect solutions we can provide. Here is shown a 2.1D or 2.3D solution. So basically what it is, it's regular laminate on which is applied a thin film with tight line width, line space capability. We can go down to 2.2. So our test vehicle is a 50 by 50, and it's particularly well suited for the application of connecting HBMs to a central chip, be it a CPU or a GPU. So, and there are other variants that can be provided. We have a monolithic laminate that can go down to line width, line space of 6.6, so it's a little bit denser than the regular laminate proposal on the market today. And these also can be organized as organic interposers. So there are a number of solutions that are well suited for HBM connectivity. And remember that in organic materials, the signal integrity and the length of the signal wire can be much greater than the equivalent solution in silicon on a silicon interposer. So another high-density interconnect approach that we're working on is our version of the silicon bridge. So you see here our test vehicle arrangement where we can join two large dies. They're 19 by 23 die connected by a smaller bridge, a 2 by 3, with the interconnect pitch of 75 microns. That's our first iteration for the demo for the test vehicle. And you see an actual cross-section of a product here, down here. So this is particularly useful for applications where you want to perform chip partitioning. And of course, it's well suited to mix chips of different functionalities. It delivers, it's really a power efficient approach, a flexible approach that can deliver high bandwidth. We're currently working with a chip pitch of bridge pitch of 75 microns, and we're planning to go down to smaller pitches. And you see that since we're working with a full thickness bridge, you need to accommodate a cavity in the laminate during the process. So, a cavity is drilled down so that we could accommodate the bridge chip there. So we have a process defined, and it is in our roadmap to be production ready at the end of 2021 or beginning of 2022. So this work is a collaboration between IBM and the Albany AI Hardware Center. I mentioned earlier how system in package is an interesting option, a popular option among some of our customers. There's a good reason for that. We have the ability to take a board level solution and bring it to a module level solution. So that makes for significant cost reductions. Moving the device technology from board to package level provides a number of advantages. You get very close die and component positioning. This provides higher bandwidth and lower power consumption. Of course, better signal integrity, and overall the smaller system level footprint makes it a more flexible solution. And you have to think about it also as an option for designing something that's modular, so that you could have a system that's much easier to upgrade and that can evolve with different technology nodes within your system. And here's a more detailed example of a solution, a system and package solution that has been manufactured in high volumes at our facility. So you see here, it's a sizable package. It's an application where that was designed on a laminate that's 60 by 37.5. So it's not your cell phone application. It's really designed for niche applications that need reliability and robustness in certain applications and environments. We're working here with a regular core laminate material, despite the large size. And here what you're seeing is a 15 nanometer die technology that's 10 by 9. What's remarkable here is the number of discrete components that have been co-packaged on this laminate. You have over 400 components, either on the top side or bottom side of the laminate, and some of these components are co-packaged with BGAs. So we can achieve a high density of components on a limited footprint. And here you have an idea of the regular ground rules that we use. This ensures that you're fitting into a menu qualification. So it's our regular ground rule with a guaranteed reliability. But of course, we're open to working with more niche applications or tighter spacings when they're required. We just have to evaluate the reliability that needs to be verified. And here you see, how we can adapt a special thermal solution for certain components that might generate more heat. So you have a central lid that's covering just the top part. In this instance, some chip scale packages are added to the component in an after process. So that's a good example of the capability, the assembly capability we can provide for certain solutions, certain applications. Another feature that can be integrated in system in package is our ability to do antenna on package. So here you see a package that's fairly large, 70 by 70, but we've integrated the antenna features, and the particularities here is that you have to maintain a very tight spacing tolerance between the antenna structures and the SLC. So we were very successful doing that and have a very performant antenna structure that works at 28 gigahertz. There are further enhancements to this approach, and we now are able to integrate further the antennas within the SLC package. So if you're interested in that, we'll be more than happy to discuss your particular applications. And one line of work that we're particularly proud of, and I think it will play a great role in integration for datacom applications, is our silicon photonics program. So here you see an illustration of how we integrate silicon photonics to regular electronics on the same package. So it's an embodiment of co-packaged optics. And to achieve that, we have a number of building blocks that can be used depending on the application. Two of those pertain on how we attach fiber optics directly to the silicon photonic chips. We have two approaches. One is fiber in V-groove, and the other one is a polymer interconnect, a photonic interconnect that mates directly to the chip through an adiabatic process. So these, the particularities of these two optical interconnects is that they are amenable to high volume manufacturing. So they're drop-in examples of how we can drop in optical interconnects to an electrical interconnect processing line and bring it to high volume manufacturing, because these are approaches, alignment approaches that are passive. Two other key elements to integration is really being able to integrate laser chips in a 3/6 material and connecting it to the silicon fabric, which is cannot be a laser medium. And the other important point on which I'll touch base is connectorization. In order to aggregate high bandwidth, we need the connectors, the optical connectors, to be as small as possible. And our packaging engineer are discussing this and working closely with connector companies to achieve the smallest footprint possible, so that we are positioned for co-packaged optics. And here you see co-packaged optics that are illustrated here. And our strategy is really to connect as many optical engines as possible to a central CPU for datacom switch fabric applications. And this really for us is an MCM. That's what it is, but it's a true embodiment of heterogeneous integration. And our special thermal lids and connectorization strategy are key to being successful to such an integration. So that's a few examples of the specialty packaging, high density interconnect packaging that we can provide to customers. Let me give you an overview of some of the base services that we can provide as an OSAT. I mentioned earlier that since 2015, we've been packaging wafers from different wafer source. Here you see we see what we've qualified on 3 different OSATs, including the Samsung qualification that we realized this week on 7 nanometers. So we have a whole set of die sort and pick capability at our facility. And here I just wanted to illustrate how we can adapt to different wafer configuration. For example, if there are features in the kerf that need to be removed, we could perform laser ablation to then be able to do a clean cut. So we have flexibility to adapt to different wafer schemes and configuration. And of course, all of these have gone to high volume production at our facility. Another key feature in our offering is our testing, electrical test and optical test infrastructure. So here you see we can provide wafer test, and our test platforms, of course, are well suited, are well adapted to the major markets that we serve, as I mentioned earlier, mainframes, high performance computing, datacom, and telecom. So I won't go into too much detail in the interest of time, but we have a full service of tests that are available to customers. Something that might not be mentioned here and that's also available is our capability for burn-in to weed out some weak hardware before the customers send them out to the field. So for specialty applications, we have burn-in capability, which is a capability that is more niche on the market. And then, we cater also to special markets such as aerospace and defense. We have full certification for ITAR and secret. So, our North American location makes us an OSAT, an interesting OSAT to keep things on the North American territory. So we have a number of customers in that market segment. And what I wanted to highlight is, of course, all the good practices that we put in protecting the IP and the traceability that we can provide on all the components that go into our module builds. Well, they're also available to other customers, of course. So it's good practices that are exportable to other market segments. And in summary, I focused a lot on high density interconnects and what we can provide as a service to customers. But we have a full array of services as an OSAT. We can take charge of your substrate designs. We have an extensive characterization and FA lab and reliability services when they're required. I touched base on our test services, and we also have modeling capability that we can provide to customers coming in with special applications, special design. So in summary, I hope I convinced you that my team has quite some interesting expertise to provide. We're qualified on 7 nanometers. We use a strong material set for high performance based on a history of building hardware for our mainframes. And we have the ability to do prototyping to high volume manufacturing. And with our development center that is in sync with our manufacturing line, we can provide some really advantageous time to market for your products. And we have an open business model. We like to consider us co-design partners once we accept a mandate from our customer. We really meet our targets. Really, my team has exceptional track record for meeting customer targets and expectations. And we can take also responsibility for your supply chain. So we have the ability to integrate the whole supply chain for providing manufacturing services to customers. So we really put all our packaging know-how at the service of customers, and so you, the customer, can focus on application and performance. So I thank you very much for listening to my presentation today. If you have any questions, I'll be pleased to answer those questions. And I wanted to also mention that my colleagues, Luc Ouellette and Luc Comtois, who are experts in packaging, will be available at the IBM booth and will be more than happy to discuss your particular needs with you. Thank you and have a nice day.